Morning. Today I'm going to show how to use the Casio's fx-570EX Classwiz calculator to numerically solve heat equation, which is one type of parabolic equation. Let's say we have a heated rod, which is positioned in the length from 0 to L and put in the x-axis at x equal to 0 up to x equal to L. It gives an initial temperature where the temperature of the rod is described by the function UTHM. So initial temperature happens when T equal to 0. That's why you have UX0. Let's say is given by Hx. This is the initial condition. And the temperature of the rod at the left end, x is equal to 0. This is why you have the function U0T at all the time t. And x equal to 0, the temperature is given is equal to Ft. This is at all the x, all the value of x, but t equal to 0, temperature is Hx. Lastly, we have the temperature at the right end here, x equal to L, So ULT equal to G2. This is a right boundary condition. When x equal to 0, there's a left boundary condition. When t equal to 0, this is an initial heat condition. And the temperature distribution of the rod is as we said, is described by the function uxt at any position x and at any time t, can be described by the heat equation del U del T equal to C squared, where C squared is a thermal coefficient, del 2U del x2, where the x from 0 to L, T is a positive value, T greater than equal to 0. We are going to solve it numerically using explicit finite-difference method. So the heat equation at the point xi dj. The x is described by the iteration variable. Its center is I, and then give increment h unit. So this point is I plus 1. The left is I minus 1. This is the vertical is a time. X-axis is a space x. Vertical axis represent the time. So at here J, this point is J plus 1. So heat equation at the point, this is the point xi dj. X is I, T is at dj. So it's del T U xi dj equal to C squared del 2 del x2 U xi dj can be simplified as del U bracket xi dj. We can simplify as U subscript I comma j. Same thing, U xi dj is as a U I comma j. So we would like to approximate or solve this heat equation. Exactly, we would like to find the temperature distribution of this heated rod at any position x at any time t. Then we use a finite difference method, and this is explicit method. So for del u del ui del uij or del t uij, del t uij. T is vertical axis, and this is first derivative. We solve it using 2 point forwards. 2 point forward. We are standing at here. So 2 point forward for first derivative, then we involve this point. So this is this point is uij. This is uij plus 1. The time increment is denoted as a k. That's why you have for 2 point forward, you take the forward point, the point ahead, you deduct the current point divided by the increment, which is delta T. K is actually the delta T. So, okay, the finite difference, okay, notation is given by Uij plus 1 minus Uij divided by K. So, equals C squared. Okay, this was second derivative, and we differentiate respect to x. Okay, remember for second derivative, okay, f double prime x, okay, or the finite difference, okay, approximation is actually given by, okay, xi minus 1 minus x, sorry. yi minus 1 minus 2yi plus yi plus 1 divided by h squared. H squared is actually where the h is actually the delta x. Okay, or sometimes yi minus 1 is actually your f, okay, xi minus 1 minus 2f, okay, f xi plus f, okay, f xi, okay, plus 1. Okay, then divided by h squared because y equal to f. So similarly for, okay, del 2 del x2 uij, we differentiate uij, okay, we differentiate respect to x. So that's why we'll take, okay, this point which is ui minus 1 j, current point uij, okay, the right point which is qi plus 1j. Okay, that's why, okay, compared to here, well, this is a function of one variable, this function of two variables, okay, but both differentiate respect to x, like we have a left point, okay, center point, and then the right point. Okay, where the y here is actually function of, okay, x, but here our function is actually the function of q, but at the time t, time t. So it's at the horizontal line. So this point ui minus 1j, okay, compared to this formula will be 1 time. Okay, the center point minus 2 times the right point plus 1 time. So divide by h squared. So this is using okay, finite difference approximation. This is using 2 point forward. This is using 3 point central or second derivative. So mean left point 1 time, current point, center point minus 2 times, right point minus plus 1 time, divided by, we differentiate respect to x, so divided by, okay, delta x squared, where the delta x is actually h, so divided by h squared. Okay, and then, okay, we solve for uij plus 1. So you have uij plus 1, it will be k here, bring to, okay, the other side, you have k c squared over h squared multiply ui minus 1 j minus 2 uij plus ui plus 1 j. Okay, this term k bring up here, so you see minus uij, so bring the right side become plus uij. Okay, and then where's the k c squared h squared, we let it equal to r. Okay, expand in, so you have r ui, okay, r ui minus 1 j, and then you have here also r ui plus 1 j. In center you have minus 2r, collect it, minus 2r uij plus uij, so you have, okay, 1 time uij minus 2r uij. So means, okay, we'll get this molecule like this. 1 time of uij plus 1, okay, this is in the, okay, equation form. We will turn it to, okay, molecule form. In 1 time uij plus 1, which is on top. Okay, I is at center, j plus 1 is on top level. Depend on r time. You see here, r time of ui minus 1j. Okay, these are all at level j. Ui minus 1 means left. Okay, I center, I plus 1 right. This why, okay, left, okay, is r time. Okay, right also r time. Center is 1 minus 2r. Okay, with this molecule, if you know the bottom level as an initial condition, and you have here is a boundary condition, then you can find this step. And then you move the target cell to here. When this is known, you move to here. Okay, like the same molecule, you can note it. So repeat it, you can solve all the level 1. Then you move up, you can solve level 2. So this is explicit. Why explicit? Because you have the targeted cell, which is only one value. Mean Uij plus 1 just depend on the bottom level. So this is you can directly get the answer. So this is explicit. Okay, if the top level you have more than one cell, then the scheme becomes implicit because you cannot solve it directly, but you have to solve it. You will get system of linear equation, and then you solve it. Solve that system of linear equation, then you can get the level 1. So that is the implicit. Let me look at that one example. Okay, we have initial temperature of a metal rod of length 1 meter is given by Ux0 equal to x squared or x from 0 to 1. So for the scheme first, x from 0 to 1, we must give you the increment of x. Delta x is h equal to 0.2. Then I draw it. Okay, I just put like a table form to be easy. So x from 0, increment 0.2, 0.4, 0.6, 0.8, 1. The initial condition is x squared. So I'm going to tabulate the initial value using the table format. So table now number 9. So the function is x squared. So alpha x squared. Starting x is 0, ending 1. It's that side h, 0.2. So you can easily tabulate the initial value using the table menu. We got 0, 0.4, 0.16, 0.36, 0.64, 1. Because we have the consistent increment, so I use a table menu rather than you calculate one by one. Okay, you can also calculate in table menu in this model. Okay, actually you can tabulate two functions. This one because I on one, so I tabulate one function. If you want to tabulate two functions together, say here you got x. So the same, starting 0, 1, 0.2, to get two functions. And then in the table modes, you can also plot the graph. So scan the QR code. So yellow color, press a shift. Okay, and then because I plot from 0 to 1. So this, the red color is your x squared, the blue color is gx, where I key in as a x. We go back here to our problem. So, as I said, you can tabulate, okay? You can use table to tabulate quickly because your increment is consistent. If the increment is not consistent, then you normally calculate. If you calculate, also you can put it x. If you calculate, then calculate 1, 2, 3, 4, 5, 6 times 0. So you get 0. 0. Equal, calculate 0.2. 2.4. So you calculate 6 times. If you calculate, you need to calculate 6 times. If you use calculate normally if the increment not consistent, but you got repeated calculation, iterative calculation but your increment not consistent, then you can use calculate menu. If you got consistent increment, we prefer to use table menu faster. Okay, we have fill in the initial condition. Now we are going to fill in the boundary condition. Okay, boundary condition are u0t equal to t exponent negative t. Okay, it's u0t. This is when x equal to 0. Okay, x equal to 0. Okay, I can put those two values. Maybe I can use calculate or I want to use table. Okay, up to you. So here, of course, in calculator, you have only a, b, c, d, e, f, x, y, m with the t. So the the t here I change it to x. X exponent, okay, negative alpha x. Okay, I use calculate menu to calculate x0. You get 0 already, so x point 0.02. You get 0.016. 0.0196. Calculate again, x is 0.04. You get 0.0384. Later on, you fill in the right boundary. This is u1t, meaning that x equal to 1, the u is 1. So the first step, draw your grids. Okay, then draw your x from 0, 0.2, 0.4, 0.6, 0.81. Okay, t increment is 0, 0.02. We want to solve up to 0.04. First step, draw the grid. Second step, fill in the initial condition. Third step, fill in the boundary condition. Okay, after that, okay, we want to fill in all the values here. Okay, this is a u when x is 0.2, t is 0.02. Okay, this is u when x is 0.4, however t is 0.02 and so on. So we've got x value to find. So, okay, the first step, okay, we draw the molecule graph. Remember, R is kc squared over h squared. Okay, this is heat equation. Approximate equation, time is 2 point forward. Okay, the delta u, del x2 at the point xi tj, approximate using 3 point central. To get this case, finite difference case notation. And then k, bring k to right side, kc squared over h squared is the R. Remember our molecule? R, 1 minus 2 R. So calculate the R value, which is kc squared over h squared. K is a delta t, which is 0.02. H is a delta x, which is 0.2. So k, h squared, c squared is from the thermal coefficient up here. This is a c squared equal to 0.75. Calculate, you got R is 0.375. So this is R, this is R, this is 1 minus 2R. 1 minus 2 times 0.375. So you get 0.25. Okay, so this molecule. So we are going to apply this molecule. Okay, apply this molecule. Okay, when I apply here, when I apply this molecule, so with U11 dependent on 0 in 0.354 times 0 plus 0.25 times this value plus 0.375 times this value. It means when I apply this molecule, you have it U11 equal to 0.375. This cell is actually U00. 0.25. Okay, because your I variable, this is 0, 1, 2. Okay, also this is 0, 1. So the Uij, U00, so this is U10 plus 0.75. to 0. Because I, okay, when at center here, U11, okay, left is 0, okay, 0, 1, 2. So this is U, okay, 1, 0, 1, 0. So this is U0, 0, this is U2, 0. Okay, we are not going to write it this way. We can quickly calculate using by inputting this one. Here, representing your left cell here by A, left bottom cell by A, center bottom cell by B, right bottom cell by C. Okay, you don't need to do it this way. U11 is 0.375 U00 plus 0.25 U10 plus 0.375 U20, and then plug in the value here. Okay, and then you plug in later on, you plug in this value 0.375. Okay, look at the value U000 plus 0.25 by 0.04 plus 0.375 by 0.16. No need to write this step, Because writing 6 times here. Okay, U11 initially plug into the formula. This formula, when you calculate U11, okay, if I is 1, J is 0. If Ij plus 1, right? Okay. So mean you plug in I is 1, J is 0. So you get U11. You plug in into the formula. You get here. Later on, plug in all the U value. Okay, and then press your calculator. Then we have a lot of steps, right? You write this one, okay, and then write the value. Then okay, plug in your calculator 0.375 times 0 plus 0.25 times 0.04 plus, okay, all these things you plug in. Okay, next time, right? 0.375 times 0 plus 0.25 times and this value 0.04 plus 0.375 times this value 0.16. You get 0.07 and fill in here. And then for this cell, we are going to repeat, write this one, press calculator. So what I'm going to do is, I'm going to key in according to the molecule. Okay, I want to calculate this targeted cell here, U11. Okay, I just input the formula 0.375. The left bottom cell, I 0.375. Okay, left bottom cell I represent as A. Center bottom, the option 0.25, I represent as B. Okay, the right bottom cell 0.375, I represent as C. And then I calculate. Okay, when I calculate here, I want to calculate U11. My left bottom cell is 0. Center bottom 0.04. Right bottom 0.16. It is similar to U. This one you write all the U. You key in the U value. Write down the U value and then you key into calculator. Okay, I'm using the calculate menu. Okay, the variable change is actually all the left bottom, center bottom, right bottom cells. The value of all these cells. So you put it into formula. So you just key in the value of A, B, C. Then you get this cell is 0.07. Okay. And then if you want to do this cell, so A now move to here. This is A. Okay, this is B. This is C. Because your target here. The target at here. Target here. So A, B, C. This is left bottom, center bottom, right bottom cell. We calculate again. A, okay, move one column to right. So A now is 0.04. B 0.16. C 0.36. So you get this value is 0.19. You get 0.19. Then move here. So you move to here. Now you want to calculate here. So left bottom, A is here. This is B. This is C. Because you want to calculate here. Calculate C. Calculate C. So calculate again. A, target at here. So left, okay, left bottom cell is A, center bottom is B, right bottom is C. So it's 0.16, 0.36, 0.64. So you get 0.39. So you get this is 0.39. Then target here. Okay, when you target at here, okay, A now move to here. This is the B, this is a C. Calculate again. Okay, target here. Okay, left is here. 0.36. 0.36. B center bottom exactly. Okay, the same column with the cell that you target. So 0.64. C 1. Okay, 0.3. 0.67. So this is a first level. This is level 0, level 1, level 2. So you completed level 1. To get level 2, now you target at here. Now you target again. When you target at here, okay, this is A, this is B, this is C. Calculate again. Now A is 0.0196. Also target at here. This is level 2. Level 2. Okay, when X is 0.2. So A is 0.0196. B is here. Center bottom. 0.07. C here. Right bottom. 0.19. Okay. 0.09. 0.0961. Then move to here. Maybe that's why you confused. So then maybe 1939. 0.19, 0.39, 0.67, 0.67. Okay, now you are going to solve this cell. So A is here, this is B, this is C. So A is 0.07, okay, B is 0.19. C is here, 0.39. So you get 0.1863. This is 0.1863. Okay, then move to here. Then this will be A, this will be B, this will be C. Calculate again. Now A is 0.19. Target here. 0.19. B is A is 0.19. Okay, B from initially 0.19 move to here 0.39. It's C initially here, now move to 0.67. Okay. 0.42 here. Okay, so the last value for the last value 0.67. Last value and target here, the target this empty cell here. A is 0.39, B is 0.67, C is here. So calculate A 0.39, B 0.67, C 1. Okay. 0.6888. Let me see. 0.688.42.22. Check 0.61. 0.22. 0.42.6888. The value next to here. Let me check this value if you want this wrong. Okay. Checking this one. This cell A is 0.07. B is here 0.19. C is 0.39. So 0.22. Okay, I took down wrong. Okay, for this cell, A is here, B is here, C is here. 8.07. We check. This is B, this is C. So this is numerically solve the heat equation using explicit finite-difference method, where your molecule is actually given by 1. This cell, one time of UIJ plus 1 is what you are going to approximate, and it depends on the bottom level, and this is R time of your left bottom cell plus 1 minus 2R time of center bottom cell plus R time of right bottom cell. So we directly apply this molecule, and we input the formula as R time of left bottom we represent as A, center bottom as B, right bottom as C. And then before you can solve it, first of all, you must, first step, draw the grids, Second step, fill in initial condition. Third step, fill in boundary condition. Later on, you target at here. Want to target at here? A is left bottom, 0. This is a B, this is a C. In your calculator, but before you key in, input the ABC, you must calculate the R first. So R is KC squared over H squared. So in this case, you plug in into the calculator, formula is 0.375A plus 0.25B plus 0.375C. And then you calculate, just calculate. So when target you 1, 1, A is 0, B is 0.004, C is 0.16. You calculate U2, 1, and move to here, so A needs you, so move one column to right. If you want to calculate, let's say U2, you move target at here, so A is this value, B is here, C is here. And you can fill up all the value inside the grids. Because your targeted cell is only one value, you can directly get the value because it depends on the bottom value. As long as you have initial condition, boundary condition. Because especially U11 you need the left boundary. At the U41 you need the right boundary. And level 1 you need the bottom level. so that you can get the top level here or level 1, okay, easily. So this method is called explicit method. Okay, and we use here the formula so that you no need to fill in, like here U11 depend on 0.375U00 plus 2.25U10 plus 2.375U20. Later on you fill in the value of U00. Okay, this cell is U00 plus UIJ. Okay, I start from 01 to J start from 01, so this cell is U00. This is U10, this is U20. So fill in the value for U00, U10, U20. So 1 step, 2 step, later on you key in a quarter, including the operation and the value. So will be times consuming. So we can directly input to the calculator 0.375A plus 0.25B plus 0.375C. Then you just calculate, just input A, B, C value instead of the write operation, fill in the value and key in the calculator, including operation and the value, which is time consuming. So with this case, thank you for your attention for the key conclusion, which is numerically solved using explicit finite-difference method. Okay, this is only using the normal complete menu. Okay, even though we have the spreadsheet menu, okay, unfortunately, it consists only 5 columns. So not enough to do the spreadsheet menu, but it need in Excel. If on Excel you don't have limitation of 5 columns, so you easily also do it in Excel, but in the exam purpose, in the examination form, you cannot bring a computer, but you can bring the calculator. So in this case, you put your attention.